Dear students, good morning and welcome back to one more session. Today in this session I am going to explain to you about the concept of net present value. In short, this concept is known to be NPV. Coming to the specification, this concept is very important for the MBA students as well as the B.TECH students. MBA second semester first paper financial accounting. Damn sure out of 100%, 96% the case study will be from this model. Okay. And next coming to the B.TECHs. Second year, second semester, first paper, MEFA paper. This model is important and the first model in the capital budgeting. So without any late, let us move into the concept directly. Here I have taken an example of NPV problem where we will be reading out the problem now and also we will solve it so clearly. Okay. Now let us read the problem once in order to understand the data. Here it has been given, calculate NPV of the following projects and comment on results. They are asking you to calculate the NPV and also asking to comment on the result. The comment means you have to give your advice whether it is good or bad, right? And next, project cost is $200. Actual cost of investment is $200. The company anticipates the rate of return at 12%. So what is the rate of return here given at 12%? The annual inflows are as given below. Here a tabulation is given which is consisting of three aspects. Here 1, 2, 3, 4, 5. 5 years data is given. And also project A. Inflows are as given below. These are inflows. Project A inflow. First year 35, second year 80, third year 90, fourth year 75 and fifth year 20. In the same manner for project B also the inflows are given. First year inflow is 18, second year 10, third year 10, fourth year 40 and fifth year 35. So from this data we have to calculate the net present value of the projects and we should give our comment. Comment means our opinion. Okay. In any problematic area we should first read out the problem and then we should write down whatever it has been given. Given, what did we facilitate with the project cost? Project cost. How much it is? $200. $200. Okay, fine. Also, the company anticipates the rate of return at 12%. Rate of return. It is denoted by small r. How much it is at a rate of 12%? Actually, it is given in percentile. So, you have to change it into the decimal form. Actually, percent means 12%. 12 per cent means 100. 12 per 100. 12 divided by 100. 12% means you have to write 12 by 100. Now, with the help of calculator, the best friend of all the accounting students, calculator is the best friend. So, let us take the calculator and calculate 12%. 12 divided by 100, okay, which is equal to 0.12. Is it clear? Then it is written as 0.12. Therefore, small r is equal to 0.12. Right, clear? Now, the next step is you have to calculate the PV. PV for 5 years. Actually, the PV rate has to be calculated. Actually, normal return is given, but you have to calculate the present value factor for all the 5 years. What is the formula? Let us know. The PV is written as PV is equal to 1 by 1 plus R whole power n, where n is the number of year, right? So now if you have seen first year PV is equal to, what is the formula we have written? 1 by 1 plus R whole power n. N means number of year. First year n is equal to 1. First year n is equal to 1. 1 by 1 plus R, how much it is? 0.12 whole power n value. N is equal to 1 here. So first year 1 is equal to 1 by, again your friend calculator, 1 plus 0.12 is equal to 1.12, right? 1.12 whole power 1 means same, value is same. Then you are going to divide 1 divided by 1.12. Let us calculate 1 divided by 1.12. How much it is? 0.892. Okay, 0.892. Up to 3 digits I am taking. You can even take it as 0.893 also. Why? Because after 2 there is 8. If it is equal to 5 or more than 5, you can adjust one number. Then you can even write 0.893. Right? Now let us calculate the second year PV. Second year PV is equal to, formula is same, 1 by 1 plus R whole power n, where n is equal to, second year means n is equal to 2. Then it becomes 1 by 1 plus 0.12 whole power 2 square it comes. Then 1 by 1.12 square. Now let us calculate 1.12 square means 1.12 2 times. So that is equal to 1.254. So is equal to 1 by 1.254. Now let us simplify this again. 1 divided by 1.254, which is equal to 0.797. Right? Second year PV factor also we have calculated. In the same way, you have to calculate the third year PV also. Third year PV is equal to 1 by 1 plus R whole power n is equal to 3. Third year means n is equal to 3. 1 by 1 plus 0.12 whole cube it comes. Then 1 by 1.12 whole cube, which is equal to 1 by 1.12 3 times. Cube means 3 times. 1.12 into 1.12 into 1.12, which is equal to 1.404. After 4 there is 9. Even you can write 405 also. So I am taking 404 as usual. Then 1 divided by 1.404, which is equal to 0.712. Okay, third year also we have calculated. Likewise, we have to calculate for all the years. Fourth year PV is equal to how much? 1 by 1 plus R whole power n is equal to 4. 1 by 1 plus 0.12 whole power 4. That's equal to 1 by 1.12 whole power 4. You can multiply 1.12 for how many times? 4 times. So simply you have to multiply 1.12 into 1.12 into 1.12 into 1.12. For how many times? 4 times. That is equal to 1 by 1.573, which is calculated as 1 divided by 1.573, which is equal to 0.635. Okay. Now fifth year, last year, fifth year PV. Fifth year PV is equal to 1 by 1 plus r whole power n is equal to 5. That means 1 by 1 plus 0.12 whole power 5. Let us simplify 1 by 1.12 whole power 5 means 5 times you have to multiply. Always instead of multiplying again and again, you can multiply the 1.2 with the previous one. 1.12 into 5 times 1.12 into 1.12 into 1.12 into 1.12 5 times is equal to 1 by 1.762. After simplifying it, 1 divided by 1.762, it is equal to 0.567. Okay, right? Till now we have just calculated the PV values of all the 5 years. Now let us take the NPV tabulation for all the 2 projects. Here NPV for project A. NPV for project A. What is the first column? Year. Year, inflow given, PV at the rate of 12%, and PV, net present value of current year. Okay. Now, how many years of data is given? 5 years of data. 1, 2, 3, 4 and 5. Right? What are the inflows given? You have to write down the inflows. Inflows, if you have seen, 35, 80, 35, 80, 90, 75 and 20. 90, 75 and 20. Okay. Already we have calculated the PV values of 5 years. What are the PV values? 0.893. These values you have to write down. What are the values we have? 0.893 first year, 0.797, 0.893 first year, 0.797 second year, 0.712 third year, 0.635 fourth year and 0.567. This is fifth year. So the same values you have to write down in the tabulation. Here I am going to write down the same. First year, what is the value? 0.893. Second year, 0.797. Third year, 0.712. Fourth year, 0.635. Fifth year, 0.567. Right. Now NPV comes. NPV is equal to inflow into PV ratio. Here we have the inflow and PV ratio we have calculated for all the 5 years. Now you are going to just multiply in order to get the NPV. You are multiplying. What is the multiplication here? First inflow 35 into 0.893, which is equal to 31.255. You can write 31.26 also. After 5 again 5 came. 5 or more than 5 means you can adjust 1. Next 80 inflow into 0.797, which is equal to 63.76, right? And then third, 90 into 0.712, which is equal to 64.08. Next, similarly, fourth year, 75 inflow into ratio is 0.635, which is equal to 47.625. You can write 47.63 after adjustment. Okay. And last, 20 into 0.576. 20 into 0.576, which is equal to 11.52. Here you are going to calculate total NPV of project A. First year NPV, second year NPV, third year NPV, fourth year NPV, fifth year NPV. So total NPV means all the 5 years you have to cumulate sum of all the 5 years NPV. First year NPV is 31.26. Second year NPV is 63.76 plus again 64.08 third year plus 47.63 plus last year 11.52. Okay, which is equal to 218.25. See, the total NPV of project A we have calculated. In the same manner, we have to calculate the NPV for project B also. Project B. Same columns. How it is? Year, inflow and PV ratio. Same. Need not to calculate again. PV ratio at the percent of 12. And NPV of project B. Okay. Now let us see first year, second year, third year, fourth year and fifth year. Now let us see the inflows given. What are the inflows given? 18, 10, 10, 40, 35. 18, 10, 10, 40 and 35. PV ratios are 0.893. 0.797, 0.712, 0.635 and 0.567. So now let us multiply these values again in order to get the NPV. Same, 18 into 0.893, 18 into 0.893, which is equal to 16.07. And then it comes to second one. What is the second one? 10. 10 means one digit it comes. Need not to calculate. 7.97. And then it comes to 7.12. Let us calculate 40 into 0.635, which is equal to 25.4. And then last year 35 into 0.567, which is equal to 19.85. Okay, after adjustment. Now let us take the NPV total of 5 years. NPV total of 5 years is 16.07 plus 7.97 plus 7.12 plus 25.4 plus 19.85, which is equal to 76.41. Here you have to calculate whether it is profit or loss. In case of project A, profit or loss, you have to calculate. So suppose if you have taken actual NPV minus cost, NPV is 218 and cost is 218.25 minus cost is 200. So here cost is 200 less cost, but return is 218. You are giving 200 but you are getting $218.25. That means $18.25 you are getting the profit. Positive means profit. Right. Here, in case of project B, profit or loss? Profit or loss formula is NPV minus cost. NPV is 76.41 minus cost is original cost 200. You are giving 200 and taking 76. 200 minus 76.41, which is equal to minus 123.59. So here if you have seen in between project A and project B, here we are having minus value. Minus value means it is loss. That means project B is not good. Project A, you are investing 200 rupees and getting 218 rupees. 18 rupees profit, $18 of profit. But here you are investing $200 but getting only $76, which is $123 of loss. So from this you can comment that between project A and project B, project A is acceptable. You can accept it because it is having profit, but project B is rejectable. Okay, that's it. In the next class we will see one more example for the NPV so that you can have the clarity. Thanks for listening.